I'm really excited to be on this Fireside chat. It's a privilege to be moderating. In some ways, I'm glad I'm not actually on the panel. As many of you know, RISC Zero and Succinct are competitive companies. They've both done a lot of incredible work making ZK more accessible and practical for developers. I've also had the privilege to talk to both of them over the years, and I can say as a former investor that these are both industry-leading CEOs. So thank you for having me on as a moderator. With that, can you please introduce yourself and your companies? Jeremy, why don't you start?
Hi, I'm Jeremy, the CEO of RISC Zero. And we were sort of the originators of the idea of using a normal ISA RISC-V to build ZK VMs. And I think that we all can agree that that model is the future of the ZK computing. And we're recently introduced Boundless, which is sort of the next phase of what we're building. And we're very excited about that and talking about that as well. So thanks.
My name is Zuma. I'm the co-founder and CEO of Succinct. We're building a ZK VM named SP1, and we're also building a decentralized prover network, the Succinct network. It's kind of a solution for all people using SP1 and ZK VMs for scalability, rollups, and other use cases. We recently launched our prover networks testnet, which maybe some of you guys saw on Twitter. And our goal is really to make ZK go mainstream this year and have this be kind of like the year of ZK.
Nice, love it. Okay, so before we dive into the future, because I want to talk about that and how you guys see it and prover networks, I want to do a quick kind of like history, a recap of what's happened over the last 5 to 7 years. And people often talk about how ZK has accelerated over the last 5 to 7 years, coming from theory into practice, both of you doing so with great products. But for many of us who haven't been following this space, it kind of seems just like a miracle overnight that we have this magical ZK technology. What have been the milestones over the last 5 to 7 years that have gotten to us to where we are today? Jeremy, why don't you start?
Yeah, I mean, I think when I so I've been following ZK for quite a long time, probably 6, 7 years ago. Actually, I started to read some of the early papers on probabilistically checkable proving. And I was super immediately interested in it because it was obvious that it would have a huge impact on decentralized systems, on every type of blockchain use case, except when at the time it was quite impractical. And I ran the numbers on some of the existing mathematical systems being used to do proving, and it just didn't pencil out to be something that would work. I think one of the big breakthroughs was Elie Ben-Sassan's creation of the Stark. That to me was when I read that paper and I did some back of the envelope numbers on how fast this would run on a GPU. I was like, wow, this is going to be something that will work. And so, I did try to convince my other co-founders at the time that ZK was the future. They didn't really quite believe it, in part because when I explained to them how one would program ZK using custom circuits, and I was like, oh, you just make some constraints over finite field elements, and they're like, what are you talking about? So I think that second step was to really figure out how to make this accessible, something that I think the industry has done a really good job of. We sort of helped pave the road for that. But I think then the rest of it's engineering. And I think that the ZKVM is already becoming commoditized. I think that the path that we set, there's lots of other folks working on it as well. Performance is, everyone is going down in performance really rapidly. And I think that we're going to see over the next year massive improvements in that. But I think that was those were some of the big milestones. Yeah, Uma, anything else?
Yeah, I think the biggest transition was when ZK went from being like a research domain to a more engineering one, as Jeremy said. And you have people who are working on engineering systems who choose, hardware-friendly fields, like small fields, who choose hardware like GPUs instead of, CPUs, and actually ruthlessly take all parts of the system and optimize all bottlenecks. And often the bottlenecks aren't like gigabrain insights necessarily to the proof system. It's actually just profiling and then figuring out even things like witness generation can be a bottleneck, which has nothing at all to do with the proof system, but then accelerating that just through performance engineering.
Yeah, I would just to agree with the fact that as you solve the problems where the obvious bottlenecks are, like the NTTs and the other sort of major cryptographic operations, it turns out that what's left, there's lots of other little smaller things, and they become the performance bottleneck. And I think that what is the reason, though, that we are still continuing to increase in speed is there's still a lot of engineering left to do. And I think that, but we've recently crossed this sort of critical threshold where now it's actually significantly cheaper to prove something in ZK and verified on chain than it is to run these things directly on chain, right? Because if you think about it, in some sense, blockchains and consensus itself is in fact a market for verifiable computation. And I think that market is going to move from consensus-based verifiable computation to ZK-based verified computation, which I think we can all agree on.
Okay, that's a great segue, because now that we have a little bit of history, I want to look at the future and understand both of your 5-year visions for ZK technology more broadly, and really focusing on what are those critical milestones, engineering, research, theory, that we need to overcome in order to get there. And Uma, why don't you start?
I think the most obvious one that we're really focused on at Succinct is rollups and chains more broadly. Like, I think right now there's kind of this separation of L1, L2, L3, all these different architectures. But in the future, it's all going to just be chains and bridges, and the bridges will all be ZK. And they're all going to, it doesn't really matter if you call it a rollup or a chain, it's just going to be ZK proofs of execution and maybe consensus if you're bridging between different consensus domains. So I'm very eagerly looking forward to the day where every rollup is a ZK rollup, every chain has ZK proofs of execution, and it just becomes more economical than paying a bunch of stakers, some inflation rate that in the end actually can be hundreds of millions, if not billions of dollars a year.
Yeah, I think, so the way we view the state of ZK over the next couple of years is really that historically the blockchain has been execution constrained. Within a given consensus domain, there's only so much block space. And as a result, there's this scarcity of capacity for executions and transactions. And when there's higher demand for execution, what ends up happening is there's a fixed, there's an increased demand, fixed supply, costs go up. And to some extent, you can solve this by making new consensus domains, but that means new validator sets, that means more different trust assumptions, and you're also creating fragmentation of the liquidity, right? So one of the things that's fascinating is that in ZK, if you build the network right, as the demand increases, the supply can also increase. And actually, if the costs ever go up above the cost of launching an AWS instance and doing proving with that, then the free market will correct and more provers will come online, right? So we have this new sort of more abundance oriented sort of way to think of execution, that as the demand for execution goes up, the cost remains fixed and there's just more execution. So we actually think, right now, if you look at it, there's something on the order of $5 billion a year being spent on the various fees and, gas, et cetera. If you look at all sort of cost to verifiable computation using consensus. We believe that not only will a huge portion of that go to ZK because it's less expensive, but in Jevon's paradox sort of sense, as the costs drop, actually there will be more people doing more new and exciting applications, and that actually the addressable market will increase even a lot more.
I'm curious to kind of dig a little bit deeper at this point. You both kind of talked about ZK in the context of essentially scaling verification of blockchains, right? Which looks like things like rollups or coprocessors. How much of would you call the market share of ZK VMs is consumed by applications that exist today, right? That just grow larger versus net new ones in 5 years?
So I think in the near term, the sort of existing, roll-ups and the verification of L2s and et cetera will be a pretty large portion of the market. But longer term, we really see the sort of emergence of newer applications that otherwise wouldn't even be feasible, right? Like I think in some sense, like the model that Hashflow, for example, is working on of this verifiable exchange is a great use of verifiable computing that is really sort of a net new, right? Or the work that, with Eigen, their slashing mechanism is actually doing computations that would be infeasible in the existing model. And actually, I think we're just beginning to see these kinds of net new applications. But like any computing revolution where the costs are dropping rapidly, it is our belief that these sort of new applications that become possible because of the new and lower costs are going to, in the long term, sort of be the majority use of ZK computing.
I think the roll-up, people's conception of what a roll-up today is actually very limited. It's usually like EVM, it's usually a general purpose chain, but I actually think roll-up as a verifiable server makes a lot of sense. And in that sense, you know, even people like Hashflow, in some sense, they are kind of building a roll-up-like thing where it's not general purpose, it's application specific. And so at some point, again, it kind of blurs the lines. Like, is it a chain? Is it a roll-up? Is it verifiable DB? Do you call it verifiable server? Whatever the name or semantics, it's just verifiable compute. And so I think we will see the adoption of all these use cases in something that looks kind of similar to a roll-up construction today, where you have this Merkleized DB that's verifiable, and you need that inherently. Like, you're not going to ZK-proof Postgres for many reasons. And you kind of have the similar semantics of like transactions or API calls, and then they get bundled together and proven. But then the range of use cases hopefully looks a lot more expressive than the activity that we see on-chain today, which is mostly trading and financialized.
Okay, so no disagreements yet. I'd like to continue on this sort of thought of you know, what do you guys hope for the future? And you know, we all have hopes and dreams that we know are maybe pipe dreams, for lack of a better term. What's one thing you hope for ZK that you don't think will come true?
I mean, you know, one thing that I actually think might be viewed as a pipe dream by some people, but I actually do think is significantly plausible, is that as ZK computing becomes more and more capable and as the costs go down, that we will see the type of expressivity and capability in truly decentralized applications that we see in the Web 2 space. Right now, there's this very strong assumption that if you want something to be decentralized and permissionless, that the cost is that it has to run at like a ridiculously tiny transaction rate and have terrible UX. And like, I mean, I think everyone wants to make that not the case, but I think that in a pre-ZK era, it just wasn't really feasible. And my hope is that ZK will effectively bring what we now consider Web 3 and Web 2 together by bringing more verifiability to Web 2 and more expressivity to Web 3 until there's really just a spectrum of different levels of decentralization across the board. But I actually don't really think that's a pipe dream. I actually think it's plausible, but it is a little bit further out, certainly. And there's some DA problems to solve that are still, I think, a little researchy.
Okay. Uma, do you want to answer my question?
I think ZKML is kind of a pipe dream. That's an answer. I think there's not that many use cases in machine learning. Or, for example, imagine Cursor or GPT-4 was verifiable. I'm not even sure there's a ton of value there necessarily. Maybe there are some use cases where if you have your LLM controlling your AI agent with certain keys or whatever, it's good for, that you're running a model that's like secure and have other guardrails or something. I've kind of seen these constructions put together, but I haven't seen anything super, super compelling in that space. And I also think from a performance perspective, it'll be very, very difficult to ever ZK prove like GPT-4, for example.
Nice. Well, one long-standing question from an investor's perspective, especially when looking at ZK VM builders, is where does value lie? Who captures value? So I'd like for both of you to share your own perspectives, and Uma, you can start. Where does value fall in the stack?
I mean, I think first to capture value, you have to create value. And I think often people in crypto are really focused on like value capture or fees, where in reality, like in some ways, the industry really needs to focus much more on like sustainable value creation that just isn't, like gambling or Ponzi schemes or tokens or whatever, right? And so I think to answer your question, like we're just really focused on like the value creation side. And I think there's a really clear economic argument there where, as Jeremy mentioned, there's so much money given to stakers today for economic security. I think a lot of that will become ZK security. If you even do some back of the envelope calculations, like 0.1 cent per transaction devoted to proving, we even have roll-up scale to 4,000 TPS, which is what Solana does roughly today. That becomes $100 million a year in proving payment. If you even take it further, like 1/100th of a cent per transaction, which we're not too far off from, 40,000 TPS, like the space needs to grow 10x for it to be meaningful at all. Again, you arrive at the same number, which is pretty substantial. And I think if you create all that value, then you can definitely capture some of it. And so I think the market is definitely like more than big enough, even just looking at the current roll-up workloads of today.
Yeah, I would agree with Uma in the sense that I think that the existing market of sort of fees being captured on chain do represent sort of a total addressable market from ZK. And I think that clearly some of that value will go to provers, some of that value will go to protocols. Some of that value may go to folks building sort of ZK VMs, although I would argue that the sort of ZK VM space is to some extent rapidly commoditizing, and that this is one of the wonderful things about the choice that I think we made to have RISC-V be sort of the standard for verifiable computing, was that it allowed us to capture this huge ecosystem of existing code out there, right? You can use normal Rust, and you can run it in a ZKVM. The one thing about standards, though, is that they lead toward commoditization. And I think that's a great thing for the industry and for all of the users of these things. It does mean that the value capture mechanism is certainly going to be a little more complex, but I think we each have our sort of plan on how it's going to work out. So,
great. So I want to revisit essentially my first question. The timelines of things over the last 5 to 7 years. The industry has changed a lot. Both of you have been building at least for several years. And as a CEO myself, I'm really curious to hear the answer to this question, which is, if you had to start your companies again today, knowing what you know today, what would you do differently?
I think that's an interesting question. I think that there have been a number of very, some minor technical missteps or places where we could have been a little more forward-looking in terms of the types of things that we did. But I think at a sort of strategic level, I think I actually am pretty happy with the direction that we've gone. I think that the decision to sort of move toward general purpose ZK and the RISC-V architecture has been borne out to be a really excellent decision. And I think with regard to sort of this next phase that we're building with Boundless, I think it just took a fair while for us to figure out what the right model was. But I'm not sure in hindsight what we could have done to make that be a faster process. And I think also there just needs to be some maturity built into the industry. So yeah, I think there's, obviously I think we could have maybe moved toward some, pre-compile mechanisms earlier. There was 1 or 2 sort of missteps with like the proving details, but we've, I think, largely addressed and moved on. And of course, this thing is that whenever you're building a new technology and you're charting uncharted territory where no one has ever built something before, there's going to be some set of failure rate, right? And so I think, honestly considering, I think it's gone quite well.
I don't know, build ZK Hyperliquid. Like, I think it's hard to say like what could have gone better, because I think we're super happy with where we're at right now, and I think path dependency is everything. With hindsight on like Succinct in particular with what we're building, one big lesson I learned is like the power of compounding and general purpose. So how we got our start was we started by building circuits for certain use cases like clients and bridging. And that was really horrible, and like it was very one-off, and we spent all this time. And none of that work ever compounded. And that's why we were so bullish on ZK VMs, because we saw it kind of solved all those problems. It made projects go from taking months to being like a weekend project. And so that was one big lesson, that general purpose and compounding things is always more directionally correct than, if you can brute force engineer your way through something now, and it's not the most sustainable, then you should kind of look towards something else.
Yeah, well, I figured there wouldn't be too much dirt because you're both market leaders, so you've done something right. And I'll actually hand it over before we wrap up. I have one more question. Show us something about your company, your people, your hiring process, your product, the technology. What's one thing that you think you do better than the rest?
I think our people are astonishing. I think that I have never worked with a better group of people, and I think that whenever we realize that there's something that we need to get done, people step up and they work through the problem. And just generally, I don't know that I could be more proud of a group of people to work with. I think the other thing I would really say I'm really proud of our company is I think that we do a really good job of trying to look for what the really correct answer is for a problem. We spend a lot of time sort of using science. Like when we went to go build our network, before we built it, we built like 3 different prototypes with 3 different models and kicked the tires on them and measured the gas cost and like worked through which ones integrated best with our customers and, really tried to I think in this industry, it is an industry that there's a strong need to move quickly. It's a fast-moving industry, but we have always believed that coming up with the right direction in the long run will guide you to success. And I think I'm really proud of us for that sort of commitment to that sort of scientific process. But yeah, also our people are just fantastic.
That must be really awesome for everyone to hear. I mean, I think any CEO has to say the people at the company, I think talent is everything, people is everything. People are the thing that makes the technology, that makes the product, that even decides what you're building. So for our team, I think I'm really proud of us for working really, really hard and also kind of being able to learn anything. One of our company values is anything is possible. And I think we've really embodied that. We learned ZK just by reading on the internet. We built all this stuff ourselves. And anytime we find a challenge, I think the team is really awesome at having this mindset of, we can, even if it seems really hard, we'll just power through and accomplish it. And it's just an awesome place to be around that environment.
Yeah, when Kevin Garnett times Succinct relationship, if anybody gets that joke. No, anything's possible. You should look it up. It's a great meme. Okay, so I think we're good on time. Okay, 0 time. I have one more question though. So I tried to get you guys to disagree a little bit. I don't think I succeeded very well. But it's no secret that RISC Zero and Succinct have had their backs and forths, and crypto Twitter is generally a very toxic place. I don't know if anybody's been on the last few days, but there's quite a few back and forths. In the spirit of being the change you want to see, I'd like for each of you to give a compliment to one another about each other's product, company, or technology.
I want to say that I actually think that you guys have done an excellent job on really good performance engineering. And actually, I think that the work you did on the precompile system was really very, forward-looking. I think that also I just want to say, while having a competitor is always, of course, a fierce, powerful competitor that's, is always kind of a pain. It's also wonderful because it drives both parties, I think, toward working harder, making better things, and the end winner of it is the customers, right? They all win when we work to make our stuff better.
Oh, thank you. I have a huge respect for Jeremy and their team. I think their engineering is really, really high quality. And I think they definitely were very ahead of their time. I think your insight to kind of make that decision many years ago when probably people thought you were crazy, that was genuinely very ahead of your time. And so, very forward thinking. So that's very cool.
Well, thank you. We appreciate that.
Aw. Okay, that's it. Thank you, everybody. Thanks, guys.
Thank you.